Um, Thank you for joining the Cavli's monthly webinar, the wireless by design. This is our second edition, and I am Prashobh with the Cavli Global Insight Sales team. So today's topic is the decoding DSI and DBI interface in display enabled IoT solutions with Cavli. In this evolving landscape of the IoT and smart embedded systems, the display interface plays a critical role in enabling a seamless user interface. Uh, the MIPI TSI and MIPI DBI are the two technologies that is widely adopted in all IoT applications, from wearables, smart automations, uh, home automations, industry automations, automotive, and so on. In this webinar, we will be decoding these interfaces and exploring the evolution um, of display interfaces, importance of digital display interface in IoT, introducing MIPI display interface technologies, MIPI DSI, MIPI DBI, their key features and applications, overview of Cavli modules and product portfolio, and the engineering implication choosing the right interface. So we at Cavli, we design and manufacture the cellular IoT modules, where we integrate eSIM into the module, and we offer connectivity through our cloud platform called as Cavli Hubble, which also enables to manage the complete life cycle of the eSIM as well as the model. So bring the three key building block of IoT connectivity. That is the hardware, eSIM, the connectivity, and the platform to manage, offering an end-to-end IoT connectivity solution for all IoT applications. So over the years, we have deployed solutions over 35 plus countries with 50 plus unique use cases where we are offered our expertise. Coming to our presence, so we are an US headquartered company based out of San Jose, California, with a global innovation center in India and a sub R&D in Vietnam. Apart from this, we have our sales and technical presence across Spain, Turkey, UK, France, Italy, and Taiwan, and we are rapidly expanding it all other regions. We are uh, the first module manufacturers to make the modules in India for the world, with our warehouse facility in Hong Kong for global distribution. So let's have a peek into the evolution of displays in embedded system. So embedded system have undergone a remarkable transformation where you can see from the early display, that is the character LCD monochrome display, to the current the smart era, high resolution, high interactive displays. This advancement came with respect to the demand of the interface expectation, the processing power, the change of communication protocol, and the power efficiency. So which enables and provide applications in multiple verticals, that is industry automations, healthcare, agriculture, automotive, and so on. So importance of display in the IoT segment is, as of now, the IoT devices generates a lot of data, which has to be viewed in real time for decision making as well as for diagnostic purposes. So, which enables more effective data visualization. Also, due to the advancement in technology, where you require more user interface or interaction with the machine is more constant. So you require high uh, graphical element required in the displays. Also, the solution also requires a compact and a more power efficient solution, which can cater the battery powered applications like the wearables, your healthcare like glucometers or portable healthcare devices, and which also needs to be adapted with the native SoCs, MCUs, and SOMs that is available in the market. So that's why which requires a very power efficient, seamless, a compact design for all the IoT applications. So we are introducing the MIPI display interface, which is a standard interface uh, protocol I can mention as which can communicate between the existing processor and the display. So the MIPI interface specifications are MIPI DBI, that is the digital bus interface, which is a low power flexible display design, which is used for small and mid-scale applications or mid-scale display applications, which offers an optimized power efficiency and a compact design. So MIPI DBI also allows communicate between the SoCs and MCUs either with parallel or series uh, data transfer can be happened. So making it much more versatile with all embedded applications. So coming to the MIPI DSI, the serial display interface, so which is a high-speed, power-efficient design, which enables high resolution, smooth graphic, and power efficient design for IoT applications, where which also provides a scalable, high bandwidth solution for your HD and dynamic interface requirements, or the solution that is graphic rich. So that's where the MIPI DSI application display can be utilized. So we are just going to the if the MIPI-DBI, the feature and the ideal use case. So MIPI-DBI is developed for the compact solution where design is very compact. There is no high-end applications or high computing requirement is there. It's just a basic display for just to view the real-time data for decision making and for diagnostic purposes. So this particular interface is very power efficient since it uses the voltage somewhere around 1.8 to 3.3 volts, making it very power efficient for battery-driven applications. And they are also very fast communicating between the MCUs and the display. So this can be enabled to communicate with TFT or the OLEDs or the LCD, like for approximate uh, resolution of 240 cross 320 with respect to the TFT, coming to the OLEDs like 128 cross 64 resolution. So which can be used for very compact device designs. So thinking about the compact nature, so in the conventional, the parallel interface, uh, you have to use a number of pins to communicate with the native MCUs or the SoCs. But in case of the MIPI DPI, it requires very fewer pins, somewhere between 4 to 5 pins, and to communicate with the display. So which makes the size very compact and reduces the size of the overall PCB. Which is a easy implementation with respect to the application, and it supports multiple data width from 8, 9, 16, 18, and 24 bits. The applications which maybe DPI are suitable is for a simple status indicators, like it can be a thermostat or a smart meter application, or it can be an HMI industry panels where it just provides with a very real-time data which can be visualized, or coming into the medical device, like you can check with the glucometers, or it can be a BP monitor. So all applications the MIPI DPI can be very suitable for. And coming into the automotive segment, this MIPI DPI displays can be used for the entry-level two-wheeler clusters. It can be also used for the EV charging station um, uh, data acquisition or monitoring as well. So moving into maybe DSI. So this is an high speed, high bandwidth interface method to communicate between the native SOCs as well as the display. So which offers speed of up to 6 Gbps per lane, and it also comes with high resolution scalable display. So it can support from HD to a 4K display with 10-bit color range. So it is compatible with all the modern displays, that is AMOLED, modern high capacitive LCD display, as well as the e-paper. Once again, the DSI is comes with a reduced pin count, uses only 4 to 6 pins and one clock, and which reduces further the PCB, which makes it very power efficient, as well as which can provide very high bandwidth for the high resolution applications. So the MIPI DSI is suitable for automotive applications like infotainment system, or it can be a high-end automotive cluster. It also goes into retail like kiosk, the POS machines, medical equipments where it requires the real-time interaction with the other medical equipments like medical kiosk. So there are multiple applications where the MIPI DSI plays a very crucial role. Just an overview about the MIPI DSI versus the other display interfaces in IoT. So as you can see that MIPI DSI offer a very high speed with a low power consumption and a high resolution that can be implemented for the high-end sophisticated applications. When MIPI DBI is comparatively low in speed but very power efficient, and which can go with low resolution displays for the low-end applications and the compact battery-driven application as well. When compared with the traditional parallel GBA or LVDS technologies. So we at Cavli, we offer a wide range of the IoT modules uh, that are based on the LTE Cat1 and Cat4 technology that supports MIPI DBI as well as MIPI DSI uh, interface solutions. So coming into our the mid-range product, that is the C10 QM and C20 QM, so which is a LTE Cat1 or a Cat4 based solution, so which uh, have a dedicated parallel MIPI DPI interface that can be integrated with the display. So currently we are offering a 3.5-inch display of a resolution of 320 cross 480 a pixel at a 30 hertz refresh rate. So which support 8-bit display, max 56 colors. So this product is based on the Qualcomm MDM9207 chipset with inbuilt GNSS, as well as the product also comes with optional eSIM as well as Hubble connectivity. Apart from the display, the module also support Yocto Linux, which can be programmed. So where we also offer built-in drivers that can support external Wi-Fi and Bluetooth module, a virtual CAN, Ethernet, and Modbus via transceiver. So this versatile module can be implemented in automotive applications, industry 4.2 application, healthcare. So it's a very versatile module suitable for uh, all the applications where it requires a very small resolution, a small size display use cases. So then we have our the smart modules. One of our entry-level smart module is the CQS 29X, the series. So which is an Android or a Linux-powered solution, currently supporting the Android 14 pack. So the module is based on either the QCM2290, more specifically for IoT application, and QWM2290 series applicable for the automotive segment. So this particular module is a Cat4 with 2G fallback, comes with a quad-core ARM processor with multiple memory configurations, beginning from 1 GB of RAM and 4 GB of or 16 GB of flash or the eMMC. So for the Linux, and it can go up to 4 GB and 64 GB. So with the multiple memory configurations. So this module comes with a built-in support for display, inbuilt Wi-Fi, Bluetooth, camera support up to 2, and with a GNSS, along with the audio support, FM. So it's all included in the module itself, which makes it very suitable for IoT applications like surveillance, kiosk, the POS machines, the infotainment system, or it can also be into the high-end clusters. So the QWM2290 version of the module is the CQS 291 and 92, which comes with the Android version of LA 2.1 with the Qualcomm middleware supporting two-wheelers and four-wheelers. The 292 series of this particular module also comes with an L5 support for GNSS. So it can have L1 plus L5 for GNSS. So, so one of our flagship modules is CQS 315, so which also support maybe DSI. So this is based on the Qualcomm SM6115 chipset. Currently, the module is available in the Android version, that is with a Service Pack 13. So this comes with the octa-core processor along with the GPU for better graphical application. So this is a Cat4 with 2G fallback with inbuilt GNSS. It also supports the Qualcomm Hexagon DSP. It also supports three cameras simultaneously. And currently we are offering the support on the Sony IMX based sensor cameras. So the resolution support of this particular module is 2560 cross 1880 at 60 hertz refresh. It supports 16.8 million colors at 10-bit display. So what choices has to be made when you are looking to have a solution to be developed with a display? So the key factors to look into is define your requirement. So it requires to identify what is your end application, what are the resolutions or size of the display which is required, what are the refresh rate, and whether the device has to be interactive or non-interactive. So these are the key aspect to look into when you go for a design, which further gets into the display type. So whether you have to choose a LCD or a TFT or OLED based application based on the nature of the use case. It can be a battery driven use case or a non-battery driven use case. Also depends upon the resolution and size of the application that you're going to build. And further ensuring the product what you have selected is compatible with the native SOM or SOC or MCUs that are available. So for easy implementation and which can further help in future proofing the solution. So which can enable you to scale up as well as long term component availability is also one of the area we have to look into when you're choosing a display solution. And finally, the cost and the supply chain risk. So cost plays a very key role in IoT solution implementation. So this could be a factor considering the overall solution. Finally, coming to our Cavli module portfolio. So we have segregated modules into different verticals or segments we can see. One is the low power IoT. So for low end applications or IoT based applications, it's based on of the NB-IoT, LT Cat M1 and Cat 1 BIS technology, suitable for agriculture applications, trackers, for asset trackers, vehicle tracking systems, healthcare monitoring, and so on. Then we have a smart module segment, which comprises of SOM modules uh, from the entry-level SOM module to the 5G levels of modules, enabling all end applications like vehicle clusters, vehicle cockpit solutions, surveillance, kiosk, POS kind of applications. Further, we have automotive grade or auto grade modules specifically for the automotive segment, comprising of modules of both 4G as well as 5G. And the other IoT modules we have is from Cat 1 is to Cat 6 technology. And finally, the broadband modules, that is from the Cat 1 to the 5G modules, that includes Cat 1, Cat 4, Cat 6, 5G Red Cap, 5G NR, and smart modules as well. So we would like to also invite to the embedded world where we are showcasing our products, and we will be present over there to interact with you, to provide you more information about our solutions, and also to discuss on your applications, where we can help enable you to have a most optimized solution that we can offer from our end. So you can meet us on uh, the embedded world, happening between 11th and 13th of March, and our stands number is 3-311, which is happening in Nuremberg in Germany. So now we are open for Q&A. So if you have any questions, we are good to take it up.
Hi, can you hear me?
Yes, you're audible.
So, why do you prefer DSI over, say, LVDS protocol? We could have gone with LVDS protocol, right? Is there any advantage in
So
Lithium 2290 or something, a mid variant which you are talking
yes,
about?
yes. So I think to address your query, I have my colleague, the senior lead from our support team. So I think he'll be taking up your question.
Okay.
So currently, the market is moving towards DSI as it is having some power advantage when comparing with LVDS protocol. And lately, most of the embedded chipset also comes with this protocol directly uh, integrated with their chipsets.
Actually, the voice was very low. Sorry.
Yeah. So I'm audible now.
Yeah, it is better.
Yeah. So currently, what we are having is like the LVDS is a legacy protocol which is being implemented, being vastly used. But when comparing with the LVDS, DSI has a slight power advantage. The consumption of LVDS protocol is bit higher than DSI, and also new generation chipsets are coming pre-equipped with a DSI protocol integrated inside it. So even in this case, if you still want to use an LVDS protocol, there is an additional IC which can be integrated, which converts DSI signals to LVDS.
Okay, okay, okay. Thanks.
Hello.
Yes, any further questions?
Yeah, so mostly, yeah. So just put more light on because I mean, what you have been promising is with the Octo A53 plus display plus cellular connectivity all in one. Is that what I'm understanding correctly?
Yes, the module is capable of the module is equipped with quad A53 if you're talking about CQS 290, and that particular module is not having Yocto, it's Android based. The Yocto based module is C10QM, and which is having DBI display capability related to it.
Understood. So I mean, it's okay. Yocto is well and good enough, but does it have the mainline support already available?
Yes, the EDKs that we provide with is already equipped with the displays that we are uh, mentioned above. I think we should go to the next slide. So yeah, so these are the two sets of EDK. The first image shows the evaluation board that we have developed for C10 QM and C10 EQM, and this is equipped with a 3.5-inch uh, uh, EDA display, as well as the CK290 comes with a DSI display, which is 8-inch size. For the if you're using the same display, we can give you the drivers as well. So we have already bring up all the drivers necessary to use these displays.
Understood. Okay, so I'm more interested into because see, we traditionally what we have been doing is we use microcontrollers and then sometimes microprocessors and then put all these cellular modules as a UART and then make the product out of it. But it's too much headache to manage. So if what you are putting here is everything into one and you do the most of the headache away from us, then that's good. So what we need is, let's suppose display support, GNS support, cellular support, and like microcontroller or microprocessor. If is that what we have already available in this any of these modules?
All those modules are capable of.
Sorry, I'm not audible.
So all these modules that you have listed meet all your requirements, what you have listed just before.
Okay, so when it comes to like GNSS support, so does it also include multiple satellites? Does it specifically include NAVIC, which is based in like India satellite?
So with respect to C10 QM, it only comes with L1 band frequency. So
Okay.
it cannot actually accommodate the NAVIC clusters. But if you're looking into CQS variants, there is 292 the most premium variant, and CQS 290, which offers L1 plus L5 support, which can cover the NAVIC frequencies as well.
Understood. Okay, so just to give you background, little bit of background. So we have been in touch with Glenn and the team. So what we were only talking about C16, 17.
Oh, okay.
Okay,
So,
so but that was only for UART, like kind of a UART based
mhm.
cellular connectivity model, which we traditionally do. But what you have promoted or put here is really interesting. So can we have whatever you have in here on C10QM
Mhm.
plus whatever is there in the C16QS and C17QS?
So you're looking for the features like display and everything, and uh, features like C17. What exact features are you looking for?
Mostly cellular and GNSS.
So cellular GNSS, everything is part of C10QM itself, even the microcontroller. But we cannot accommodate L5 because the GNSS part is pre-integrated in the baseband chipset itself. So the limitation with L5 band to be accommodated is with the baseband processor that we use.
Okay, so because see, I don't really understand too much on like
Yeah.
level 5 or level 3, what you're saying. So what is the accuracy level which we can get it with a C10QM when it comes to
Uh,
location?
with I'll give you accuracy figures of C16, C17, and C10 QM. So C16 QS can give you an accuracy of less than 2 meter CEP.
Mhm.
And when coming to C17 QS, if it's the GNB variant, it can go to less than 1 meter, and the CT and QM can give you an accuracy of less than 2 meter.
Understood. Okay, so one more thing, right? I'm sorry for a lot of questions, but
No
so
issues.
yeah,
Happy
so
to.
yeah, is there a way we can get centimeter level accuracy?
Centimeter level accuracy.
Yes,
Uh,
maybe 5-10 centimeter accurate. It doesn't have to be 1-2 centimeter.
so at the moment, no should be our answer for that. This accuracy figures that what we present, it's not the actual accuracy that we are getting, it's the maximum deviation that you can observe. So, uh, in most cases, it is giving an accurate result. But even if it deviates from that particular point till 2 meter, it is in line with our specification. That's what we can come up with.
Okay, got it. Okay, sounds good. And how do we order these evaluation boards?
You can just reach out to us. I hope you're already in touch with Glenn. So you
No,
can just
okay, so we were very specific. We didn't know all about all your other products like this. I just happened to know and register for this. I mean, this is really promising and puts a lot of our headache away. Yeah.
sure, sure. So I think we will be it is better that we can have a web call and where we can also give you a walkthrough of the products suitable for your requirement. Like what are the options that we can offer based on various aspects. We can just look into it.
Okay, sounds good.
So do you have any further questions?
No, thank you.
Okay, yeah. So we have any questions from other attendees?
So I'm looking for a solution for my EV charging needs, which will allow me to view the real-time data. So which of your options would be more suitable for this requirement, the Ceton QM or the CQS 29X series?
It depends upon your requirement. Like if you would like to have a very basic your display solution, like you just want to get from some data to be reviewed or just for analytic purposes. So you can just go with the maybe DBI solution, or if you want to have more interactive display option, that way you have where you can interact with the display for the multiple charging lines or to allocation of the chargers for the EV. So these requirements, then you have to go with maybe a DSI option. So also it depends upon your requirement based. So we can if you're able to connect with us, we can just look into your requirement more further, and we can suggest you a suitable solution based on it.
Okay, sure. Thank you.
Yeah, thank you. So I hope there are no further questions. So if then we can wind up this particular session. So I would like to thank all the attendees for joining us for this particular edition of our monthly webinar, Wireless by Logic, um, Wireless by Design, and we look forward to for our next webinar, and we'll be also providing more details into other areas of technology and how we are able to help in seamlessly provide the solution and integrate uh, uh, into the application that you're working on. So thank you all.